Hey guys, this is Shula from ShulaTutoring.com, and I'm about to go over some examples involving sum and difference identities. So I have an example right here, problem 2 sine pi over 3 minus x is equal to 3 times tangent of pi over 6. So let's start. First, we will use our identity right here. So 2, and then everything that follows has to be in parentheses because 2 is multiplied by this whole thing. So whatever this thing is going to expand to is going to have to be multiplied by 2 as well. So 2 multiplied by our formula is right here, right? So sine A, or sine pi over 3 times cosine B, so cosine x, minus cosine A, or cosine pi over 3, times sine B, or sine x here, right? Because our A is pi over 3 and our B is x. And here we can also simplify because we know what tangent of pi over 6 stands for, right? Because tangent of pi over 6 would equal to sine pi over 6 over cosine pi over 6. So pi over 6 is the 30-degree angle. So at 30 degrees, the sine is 1/2 and cosine is a square root of 3 over 2. So this is gone and we're left with 1 over square root of 3. We don't like to leave square roots in the denominator, so we have to rationalize this fraction. We multiply both sides by square root of 3 and we get square root of 3 over 3. Okay, so this is our tangent at pi over 6, so we just write it here instead of tangent of pi over 6, right? So we write square root of 3 over 3. And now let's simplify this further. Sine at pi over 3 is square root of 3 over 2. Square root of 3 over 2 times cosine x minus cosine at pi over 3, right? Pi over 3, that's a 60-degree angle. Cosine is going to be 1/2. So 1/2 times sine x, and this is gone. So we're left with square root of 3. So now we can just distribute the 2, right? We multiply both terms inside the parentheses by 2. So we are left with square root of 3 cosine x minus sine x is equal to square root of 3. At this point, we can just combine like terms, right? We put the square root of 3 on one side of the equation and then sine x on the other side of the equation. So to do that, I have to subtract square root of 3 from both sides and add sine x to both sides. So I get square root of 3 times cosine x minus square root of 3 is equal to sine x. So what do I do at this point? Well, I notice that I have a common factor on the left side of the equation. So my common factor is square root of 3. So I can factor it out. So when I factor it out, I'm left with cosine x minus 1 inside the parentheses is equal to sine x. So now I need to find a way to simplify this. Usually we simplify square roots by squaring them, right? But whatever we do to one term or whatever we do to one side of the equation, we have to do to both sides of the equation. So let's square both sides of the equation and we are left with 3, right? Because square root of 3 squared is 3. And this whole parenthesis is squared is equal to sine squared x. So what do I do at this point? So at this point, I will erase this part because I need more space. Okay, what we have in the parentheses right here is squared difference of two terms. Squared difference of two terms, if you remember, is a minus b squared, and it expands to give us a squared minus 2ab plus b squared. Right, so we can use this formula to expand this parenthesis right here. And what do we do for our sine squared x? Well, there is another formula that says that sine squared x plus cosine squared x is equal to 1. So this formula is useful to us because if we want to have a chance of solving this or simplifying this, we want to have either cosines or sines. So this formula provides us with a very simple way to convert sine squared x to an expression involving cosine squared x, and then we will be able to solve the whole equation. So sine squared x is equal to, if we subtract cosine squared x from both sides, sine squared x is equal to 1 minus cosine squared x. So that's what we can write instead of sine squared x. So let's do that right now. First, what I'm doing, I'm expanding this parenthesis. 3 times cosine squared x, right? A squared minus 2 times 1 times cosine x, right? So times 2 cosine x plus 1. So I just use this formula right here, is equal to 1 minus cosine squared x, right? So I wrote 1 minus cosine squared x instead of sine squared x. So now I will just distribute the 3, right? So I write 3 cosine squared x plus 3 is equal to 1 minus cosine squared x. At this point, I want to again combine like terms. So to combine like terms, I would have to add cosine squared x to both sides of the equation, and I would have to subtract 1 from both sides of the equation. So let's see what I get. I get 4 cosine squared x minus 6 cosine x plus 2 is equal to 0. What we can do to simplify, we can factor out 2, then we get 2 cosine squared x minus 3 cosine x plus 1 is equal to 0. So what I do now, I just drop the 2, right? Because if we were to divide both sides by 2, 0 divided by 2 is 0. At this point, I will rewrite this on the next page to make it easier for me to work with because I need more space. So what do I do at this point? You might get a little bit confused because of all the cosines there, right? But this is very similar to what you probably did in algebra. Like if you had 2x squared minus 3x plus 1 is equal to 0 in algebra, you would know what to do, right? You would just need to factor it. You need to find two factors that when multiplied give you 1 and that when added will give you minus 3. And then one of the parentheses will have 2x and one will have just x. And because we just have 1, the factors of 1 are 1 and 1. So the only question is the signs. Well, with the first sign being minus and the second sign being plus, we are left with only this option, right? Minus and minus. So let's FOIL it and see if we did it correctly. So we get 2x squared minus 2x minus x plus 1 is equal to 0. 2x squared minus 3x plus 1 is equal to 0. Perfect. So we did it correctly. So this is the way to factor this into two parentheses. So let's do the same thing here. Just use cosine x instead of our x. So we get 2 cosine x minus 1 multiplied by cosine x minus 1 is equal to 0. So now we just break it apart and we get a few solutions. So we say 2 cosine x minus 1 is equal to 0, or cosine x minus 1 is equal to 0, right? Because one of those parentheses has to equal 0 in order for the whole expression to equal 0, because anything multiplied by 0 is 0. So here we just add 1 to both sides, and also here we add 1 to both sides. So we get 2 cosine x is equal to 1. Here we get cosine x is equal to 1. And then where is cosine x equal to 1? Well, cosine x is equal to 1 at 0, or 2 pi, or 4 pi, or any multiple of 2 pi, then our cosine will equal to 1. So x is equal to 0. Why am I only writing 0? Because our solutions here are restricted from 0 to 2 pi, but 2 pi is not included. So I can't really write 2 pi. So the only solution from cosine x is equal to 1 is really 0. Now I just divide by 2, and then I get cosine x is equal to 1/2. So where is cosine x equal to 1/2? So we have angles that are closest to the horizontal axis: 30-degree angle, 150-degree angle, 210-degree angle, and 330-degree angle. So for those angles, the cosine is going to be square root of 3 over 2 always. It will have a negative sign in the second and in the third quadrants. So if you want to just remember the values of the unit circle, right? So if you have those angles that are closest to the horizontal axis, the cosine is always square root of 3 over 2. The sign is 1/2, but some of them could be negative or positive depending on the quadrant. So the opposite goes for the angles that are closest to the vertical axis, right? So if this is 90 degrees and this is 270 degrees, then those are going to be the angles that are closest to the vertical axis. So it's 60-degree angle, 120-degree angle, 240-degree angle, and 300-degree angle. For those angles, the cosine is always 1/2, and the sine is square root of 3 over 2, but some of them are positive or negative depending on the quadrant. Yeah, so here cosine x is equal to 1/2. Well, this is going to be our angles here, right? Closest to the vertical axis. And where is cosine positive? Cosine is positive in the first quadrant and in the fourth quadrant. So this is going to be pi over 3, 60-degree angle, and 300 degrees, or 5 pi over 3. So here and here. So let's write that. X is equal to pi over 3 and 5 pi over 3. So that's basically 60 degrees and 300 degrees, just so that we keep track of everything. Okay, so you might say we have 3 answers. Let's just go, right? We're done with that. No, we're not done. The reason we're not done is because not all those answers are going to be real answers. So we have to check, we have to plug in the angles that we got into the original equation and check if they actually work. So let's see. So let's first check for 0, right? If x is equal to 0, then what? Well, 2 sine pi over 3 minus 0 is equal to, well, we know that this whole value is square root of 3, right? We solved for that already. So 2 sine pi over 3 is equal to square root of 3. Okay, so sine of pi over 3, pi over 3 is a 60-degree angle. For those angles, the sine is going to be square root of 3 over 2. So 2 times square root of 3 over 2 is equal to square root of 3. This is gone. So we are left with square root of 3 is equal to square root of 3. So x is equal to 0 actually works. This is a real solution. And then let's check for 60-degree angle. If x is pi over 3 then what? Well, 2 sine pi over 3 minus pi over 3 is equal to square root of 3. 2 sine of 0 is equal to square root of 3. Well, sine of 0 is 0. So 2 times 0 is equal to square root of 3. Is 0 equal to square root of 3? No. So this solution doesn't work. This solution is not a real solution. It's an extraneous solution. Let's see for the next one. It should work, but let's check just in case. If x is equal to 5 pi over 3, 2 sine pi over 3 minus 5 pi over 3 is equal to square root of 3. 2 sine of negative 4 pi over 3 is equal to square root of 3. What is negative 4 pi over 3? First of all, let's look at our unit circle. So first of all, what is negative 4 pi over 3? So negative 4 pi over 3 is a negative 240 degree angle. So what is negative 240 degrees? Well, when we do our positive degrees, we go in this direction, right? So we go counterclockwise. When we do negative degrees, we go clockwise. So let's try to find our negative 240 degree angle. So this is 0, right? That would be 90. This would be 180. Negative 180, right? I'm going clockwise. This would be 270. So this angle is going to be negative 240 degree angle. 180 plus 60 is 240, right? So this is a negative 240 degree angle, or it's a positive 120 degree angle. For this angle, the sine of this angle is going to be square root of 3 over 2, because it's one of those angles that are closest to the vertical axis. So 2 square root of 3 over 2 is equal to square root of 3. Yeah, so that works. So we have two solutions. Our solutions are x is equal to 0 and x is equal to 4 pi over 3. Both of those solutions fit within the restriction that we're given, and we checked if they work. Right, so what have I done in this problem? Well, first of all, I applied our difference identity for sine right here. And then I went ahead and I simplified, right? I distributed the two. And then I combined like terms, and then I factored out our common factor. And then I used this formula for the difference of two terms to expand this, and then I converted sine squared x to an expression involving cosine squared x. And after combining like terms and simplifying, I was able to get to an expression that's actually factorable. This is our factorable expression. Once you factor, it gets pretty easy, right? Because you have two very simple problems instead of having those three terms and one of them is squared, right? So this is a much simpler situation here. And then I got three answers, and once you get your answers, all you have to do is just check how many of them work. Very often you find answers that don't really work, that are extraneous. So that's it for this one. Let's do one more. So this is one where we apply the formula for cosine. So here we have cosine x plus 4 plus cosine x minus 4 is equal to negative, right? Negative 2 times cosine of pi over 4. Let's solve this. And again, we have this restriction. So cosine x times cosine pi over 4, right? So I'm just applying the formula. Very important to remember, when you apply the formula for cosine, you have to flip the sign, not the sign cosine. You have to flip the negative and the positive in the formula. So here I have positive. When I apply the formula, when I expand, I have a minus here. So then I have sine x, sine pi over 4 plus cosine x cosine pi over 4 plus sine x sine pi over 4 is equal to minus 2 times, well, cosine of pi over 4 is square root of 2 over 2. I'm already starting to simplify things here. Cosine at pi over 2 is square root of 2 over 2 times cosine x minus sine at pi over 2 is square root of 2 over 2 times sine x plus, again, square root of 2 over 2 times cosine x plus square root of 2 over 2 times sine x is equal to, this cancels out, right? So we are left with negative square root of 2. Let's simplify. We have negative square root of 2 over 2 times sine x, and here we have a positive square root of 2 over 2 times sine x. So they add up to 0. So let's rewrite this, and this we can add up, right? It's the same terms that we just add. So we get 2 times square root of 2 over 2 cosine x is equal to negative square root of 2. And this simplifies, so we're left with square root of 2 times cosine x is equal to negative square root of 2. And now we can just divide by square root of 2. So here we have 1. So cosine x is equal to negative 1. So where is cosine x equal to negative 1? Cosine x is equal to negative 1 at pi. So x is equal to pi. We could have more solutions, right? Because every time we do a revolution around the unit circle, anything that's pi plus 2 pi, then we would have cosine x that equals to negative 1. But we have this restriction, so we have to leave our answer just at pi. So those were two practice problems that used sum and difference identities for sine and cosine. So I hope that this content was useful to you. If you have any questions, please mention them in the comments below. If you enjoyed watching this video, please like this video and subscribe so that you don't miss future content. See you soon. Bye bye.